Welcome to Cognito Key. Have you ever stopped to think about what makes your phone, your tablet, your computer just so fast? Well, a huge part of that magic comes down to this really simple but brilliant idea for designing processors. And today, we're going to dive right into it.
So here's our roadmap. First up, we'll get into what a RISC processor actually is. Then we'll take a peek at its special reduced architecture. After that, we're going to talk about a super cool trick called pipelining that makes everything faster. And finally, we'll look at the good and the bad, the advantages and disadvantages.
All right, let's start at square one. I've been saying this word RISC, but what on earth does it even stand for? And, why should you care? What does it actually mean for the gadgets you use every single day?
Okay, so the name itself is a huge clue. RISC stands for Reduced Instruction Set Computer. The whole philosophy here is kind of counterintuitive. Do less to get more done. It's all about using a really small, super optimized set of commands to get the job done. And that word reduced is everything. Seriously, the whole idea behind RISC is simplicity and speed. And it starts with this. Every single instruction is super, super simple. It does one tiny, basic task, and that's it.
Now, this simplicity has a really cool side effect. Because every instruction is so basic and always the same size, it's really small and tidy. So small, in fact, that each one fits perfectly into what we call one word of computer memory. No wasted space, just neat and clean.
And what do you get when you have all these simple, tidy, single-word instructions? You get speed, like blazing speed. We're talking about the processor knocking out most instructions in just a single tick of its clock. Think about that. One tick, one instruction done. That's the secret sauce right there. It's just beautifully efficient.
Okay, but how? How is the processor actually designed to be this fast? For that, we've got to pop the hood and take a look inside at the reduced architecture. Let's see how it all comes together. So there are two really big design choices that make a RISC processor special. First, it uses what's called a hardwired control unit. Now, what does that mean? It means the instructions are physically baked right into the circuitry. They're not software, they're hardware. This makes them permanent, but also lightning fast. And second, there's this massive focus on using the processor's own super-fast internal memory, called registers. And this focus on registers, it's absolutely critical. Here's a good way to think about it. The registers are like a workbench right in front of you, with all your tools laid out. The main memory? That's like a toolbox on the other side of the room. A RISC processor wants to do all its work right there on the bench, using the data, we call them operands, that are already in those speedy registers. But okay, what happens when the thing you need is in that toolbox across the room, in the main memory? Well, that's where two very special instructions come into play. Load and store. It's simple, really. The load instruction goes and gets the data from memory and brings it to your workbench, to a register. And the store instruction, it does the exact opposite. It takes the finished work from your bench and puts it back into memory.
So you see the workflow, right? Load it, work on it super fast in the registers, and then store it back. It's a clean, simple process. But what's really amazing is that this simplicity opens the door for another incredible performance-boosting technique. And that, my friends, is called pipelining.
Pipelining is brilliant. It's just like a factory assembly line, but for computer instructions. So instead of taking one instruction, finishing it completely, and then starting the next one, the processor overlaps all the steps. Just look at this example here. While it's busy executing the first load instruction, it's already grabbing the next one. And while that second one is executing, it's already starting to do the math on the first two. It's multitasking at a tiny, tiny scale.
You can just imagine how much time this saves compared to doing everything one after another. And this is only possible because, remember, every instruction is simple and takes pretty much the same amount of time. The performance boost you get from this is huge. We're talking about nearly doubling the speed of execution. That's a massive win.
So, this all sounds pretty perfect, right? An elegant, super fast design. But, in engineering, there's no such thing as a free lunch. It's always about trade-offs. To get all that incredible speed, you have to give something up. So let's get real and take a balanced look at the pros and cons.
All right, let's start with the good stuff. The reasons why RISC is so incredibly popular. It's really everything we've just talked about. You've got those simple instructions, the super fast execution, one instruction per clock cycle, and those hardwired circuits. It all comes together to make a processor that's not just fast, but also really power efficient. This makes it perfect for pipelining and absolutely essential for things like your phone, where every drop of battery life matters. But there's always a but, isn't there? That amazing simplicity comes with a price tag. Let's flip the coin over. See, because each instruction does so little, if you want to do something complex, you need a lot of them. That means your programs end up being longer. And remember how the instructions are hardwired into the chip? Well, that makes them really hard and expensive to change if you need to. You can think of it as a specialist, not an all-rounder.
So at the end of the day, it all boils down to one fundamental trade-off. RISC basically says I'm going to give up having complex instructions, and in return, I'm going to get raw speed and efficiency. That's the key takeaway here. It's a deal. Longer programs, but for way simpler and therefore much, much faster hardware.
And that simple idea, that less is more, has truly become a foundation of the computers we use today. Which leaves us with a really interesting question to think about, right? This simple, elegant design is the engine behind our incredibly complex world. So, what's next? What will be the next beautifully simple idea that changes everything all over again?
So if this explainer helped you understand a little bit more about the magic that's happening inside your gadgets, we'd love it if you'd subscribe to Cognito Key. And of course, don't forget to like and share this video. Thanks so much for watching.